G'day mate, today you're going to be talking to yourself about the presentation of data. Now, the factors that you should consider when presenting your data is the accuracy versus the likelihood that you're going to remember. Okay? The most accurate being just a table, but a bunch of numbers like that isn't really going to help you remember the general trends. Which is probably the most important part. Also, no clutter. Okay, but that's more in the formatting of the graph and less in your presentation of the data. Now first, you have to analyze the type of data. For example, in a stack of variables including your name, your weight, your height, your age, your gender, and your level of education. And you have to be able to identify this as a class identifier, these as continuous variables, which you will round off into decimal place for simplicity, this as your nominal variable, and your level of education as ordinal. You can also have discrete data, such as number of times you have played Angry Birds. That was necessary. Make sure you remember that. Now you should always define your variables, the types that they are, the scale if they're measured, for example, no example. And their levels if they're categorical. Now, nominal and ordinal data are best shown using a bar graph. Right? For nominal data, you want to use a Pareto bar graph, which simply organizes everything into descending order and potentially has an other column here. This will be last despite its size because it includes many little inputs. Now this will show the general trends, the relative proportion, so that this is like 80% of the one next to it. You can tell just by its height. And it is most importantly very memorable. Now ordinal data is effectively the same, except the order is important. Therefore, you can't reorganize it into a Pareto chart. So you should just keep it as a random bar chart. What this often allows you to see will be modes and means. We'll talk about that a little bit later. Also acceptable, is a clustered bar chart. So you can have, say, gender here, male and female, and then different information about each gender. This helps you find the general trends across bivariate data, because you're taking their gender, which is one variable, and say their weight and grades as another. For discrete and continuous data, you're going to be wanting to use histograms, dot plots, line graphs, or stem and leaf plots. Okay. A data set, again, just a random assortment of numbers, is the most accurate but the least useful. Histogram, whilst not good for continuous data, because it shows a range, it is quite good for spotting general trends. Okay? So, for discrete data, you will have a range, so A to B, B to C, C to D, in each bin. The area of the box, generally the width being the same means the height of the box, is what defines the occurrence of the frequency. And this isn't good for continuous data because it just bins all the variables. However, what you can do is a dot plot. This will show you the continuosity of a data set and will show you trends. However, for discrete data, it's often unnecessarily messy. Now you get shape descriptives as well. Now, a symmetric bar graph will, obviously with bars, look like this. Simply draw a line in the middle, they're the same. An asymmetric or skewed bar graph will look like this, or this. This is a right skew because the tail of a rat, per se, goes to the right, also known as a positive skew. And this is a negative skew because the tail goes to the left. There is unimodal, such as these, or there is bimodal, or even multimodal. A mode is simply the most occurring value. Okay? Generally, these occur in a heterogeneous collection of different averages. For example, the height of a man and a woman, taken simply as the height of all people, will look something like this. Because here you'll have the women's height, here you'll have the man's height. Now, the stem and leaf plot will help you maintain accuracy. However, in the process, you can no longer plot complicated and extensive data sets. Okay, the stem and leaf plot looks like this. 1, 2, 3, 4, 5. Not important what these values are, you can even repeat and split the set. For example, 1, 1, then you have 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. But generally, what happens is you'll write a bunch of numbers here, keeping them evenly spaced apart, and they will form a histogram-like shape like this. Okay? Good thing about this is it allows you to see, especially if you order these in ascending order from 1 to 9, you'll be able to see the exact values while still getting a kind of shape, general trend visualization of the data points. Now what's quite good about this is when this is 1 and this is say 2, that can be any number of things. That can mean 1200, it can mean 0.0012. Okay? You set this out in your key. So in your key, you write number x bar number y, x plus y times 10 to the power of z. What that basically means is 7 is equal to 37 or 3.7 or whatever. On Minitab, the first column will indicate the number of values counting up from the middle. So if this is 1, 2, 5, and this is 3, 4, 5, what this means is there are 3 values here, 1 value here, 1 value here, 1 value here. So the addition keeps going up, and then in the middle, which is where you'll find your mean, is the collective half. Sorry, the middle is where you find your median. Now, with bivariate data, it starts to get a little bit more complicated. You won't really find bivariate qualitative or categorical data. Generally, you'll find one of each, categorical and numerical. What you'll do for this is you'll split it up into the categories. That is not a poo. You get male and female here, for example. So your categorical data, in this case it is not ordinal, nomical, there we go. And you'll get the extent of your numerical value from the height here as a histogram. This can be seen in, say, population pyramids. Now, if you have two numerical, what you're going to do is a scatter plot. So this has one numerical axis, this has another numerical axis, and then somewhat randomly dots scattered around. You can spot general trends, say, like this. These will be things like exam scores and distance from university. Okay, it shows that the people who live further from university tend to get higher scores in the exams.